All right, so this video will focus on 10.2. And the first thing we're going to do is look at evaluating these expressions. And I want you to notice two things. Number one, I have the base, which is my 3, and my exponent, which is 5. So this means 3 to the 5th power. So 3 times 3 times 3 times 3, 5 times. And the grand total, when I multiply these out, will be 243. This is 5 to the 4th, so 5 times 5, and I do that 4 times, and I have 625. 10 to the 6th is 1 million. Now, this is something I want you to pay attention to. See how it's a negative 4 to the third? That means negative 4 times negative 4 times negative 4. That means my answer will be a negative, and it will be equal to negative 64. This one here is going to be negative 3 times negative 3, which is equal to positive 9. Negative 2, and I do that 5 times, which is a non-number. So my answer's got to be a negative 32. What we want to do today is figure out how you could use inductive reasoning to observe patterns and write general rules involving properties of exponents. So if I look here, I have 2 to the 4th times 2 to the 2nd. And when I multiply this, I do 2 times 2 times 2 times 2 times 2 times 2. That's what this is saying, 2 times 2. And then this 2 times 2 4 times. Well, altogether, I have 2 to the 6th power. And that's what it's equal to. When I look at the other one, or the next one, I have negative 3 to the 2nd, which means negative 3 times negative 3. Notice that it's in parentheses. That's why I'm multiplying it like this. These are going to be then 4 more of these. So 1, 2, 3, 4. Altogether, I have 1, 2, 3, 4, 5, 6. So I have negative 3 to the 6th power, which means my answer's got to be a positive, right? But that's how I would do this. 7 to the 3rd, 7 to the 2nd, I just add those together. And that's kind of what I'm going to start doing. I just look at my base, and I add my exponents together if the bases are the same. So this one here would be like 7 to the 5th, 5.1 to the 7th, negative 4 to the 4th, 10 to the 8th, 1/2 to the 10th. If I look here at this here, this is something a little bit different in the sense that now I'm going to actually go through and I'm taking a group. So if I have like 3 to the 2nd, that really means 3 times 3, but I'm doing that a total of 3 times. So I'm going to take this and kind of replicate it. So I have 3 of these. And altogether, when I look at it, I'm going to have 3, or 2, 4, and 6 of them. So it'd really be 3 to the 6th. Now, the other way I could have done this is I could have taken 3 to the 2nd, and there's 3 of those, so 2 times 3 is 6. Let's see if it continues to hold. So if I have 2 to the 2nd, so that would be 2 times 2, but it says I had that 4 times. So then 2 times 2, 2 times 2, and one more, 2 times 2. Now, altogether, how many 2's do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 2 to the 8th power. And if I look at 2 times 4, I do get 8. So this would be 7 to the 6th, y to the 9th, and x to the 8th. Now, we're going to expand this out a little bit more just because whenever I have different numbers within my parentheses, it means different things. And I'll show you what I mean. So this base is 2 times 5, and really this means 2 to the 2nd times 5 to the 2nd. So another way I could have written this one, if I wanted to, would be 10 to the 2nd power, right? This one here is going to be either 20 to the 3rd power, or I can do 5 to the 3rd times 4 to the 3rd. Now let's make sure this works and this holds true. So if I look at this one here, this would equal 4, because 2 times 2 is 4, and this would equal 5 times 5, which is 25. And we know that 4 times 25 equals 100, right? And this is 10 to the 2nd, so that means 10 times 10, that also equals 100. So if I look here, these are equal to each other. I'm just double checking these to make sure that it really works. 5 to the 3rd is 125. 4 to the 3rd is 16, and then 64. And if I take 125 times 64, let's just try that. So I'm going to take 125 times 64. I get 8,000. And 20 times 20 times 20 also equals 8,000. So that's why this works. Okay. Now if I look at this, if I have this here, I will have 6 to the 4th times a to the 4th. I'm showing you this because if I take 6 to the 4th, that means 6 times 6 times 6 times 6. And that equals 1,296. But I still have a to the 4th as well. So that's my answer. This one here would be like 3 times 3, which is 9. But then I also have to apply the squared to the x, so it'd be 9x squared. So we're going to go through, and these are the various properties that we've kind of learned. If you have the bases are the same, you just add them together. If you have numbers in parentheses, so like 4 to the 6, and then 3 groups of those, I'll just multiply together. That's what this property is showing you. And then finally, the power of a product property is if I have like 3 times 2, I'm multiplying my bases, and then putting that other exponent on top there. So first you multiply whatever's in parentheses, and then apply the exponent, which is what this is saying. And it can be written just like this. So these are really the 3 properties that we've already learned today. So if I look here, the bases are the same. So if I look at that one, I'm essentially doing the power of a power property, right? And in this case, a product of a power property, sorry. So that would be 2 to the 20th, or 2 to the 9th. This one here would be the same base, just like I had before. But this is like to the 1st, so this would be -5 to the 7th. And this here would be x to the 10th, right? So these are all the product of a powers property. Here's the other one, where I have my 3 to the 4th, so groups, and I have 3 of those, right? So this is power of a power property. This is also power of a power property. This here, I'm going to apply this to both. So this would be like 2, so this would be 8x cubed. This here would be 9x squared y squared. And these are all power of a product property. So here's a couple more. I want you to pause the video, try to solve them, and here are the various answers. We have this one here. This is an interesting problem. It says that there's a gigabyte, which is 2 to the 30th, right? And the details of the computer are shown. So if I look here, for instance, I have my total space, which is 64. So 64 gigabytes, and each gigabyte is 2 to the 30th, right? So if I think about 2 to the what power equals 64? Well, 2 times 2 is going to be 4. Let's just write this out. So if I do 2 times 2, that's 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. And if I look here, that's 1, 2, 3, 4, 5, 6. So this can be written as 2 to the 6th power. I'm doing this because I'm trying to have the same base as this one. And then I said times 2 to the 30th. Well, this is that whole power of power thing, right? That if I look at it, it's 6 plus 30, which is 2 to the 36th power. So that's the power of a product, or the product of a power property. This one here says how many bytes of free storage are there? Well, again, before there are 16, so 2 times 2 is 4, times 2 is 8, times 2, so that'd be 1, 2, 3, 4. So that'd be 2 to the 4th times 2 to the 30th. So that'd be 2 to the 34th, right? And that's really the lesson for the day.